Hey Chem fam, we are going to try some different half-life problems out. A couple things. This is from our worksheet number 2. So let's try a few things just to make sure we are feeling confident. Number 1 says the half-life of cesium-137 is 30.2 years. That means that every 30.2 years, half or 50% of that sample decays into something else. It looks like the initial mass of the cesium-137 is 6 kilograms, so that would be our starting mass. We want to know after 181.2 years, how much of that 6 kilogram sample remains. So we want to know our final amount of kilograms. All right, well, let's do it. If we make ourselves a chart and put half-lives, the mass, and then the length of time, which looks like we're going to be dealing in years. All right, so we always know if 0 half-lives have gone by, 0 years have gone by. And since we started with 6 kilograms, that would be natural at time 0. Now, after 1 half-life, we know 30.2 years goes by. Why? Because that's what a half-life length is for this specific isotope. That means after 2 half-lives, another 30.2 years would go by, which would add another 30.2 years, which would be 60.4. All right, but remember, after 1 half-life, this 6 kilogram object now becomes 3 kilograms. You cut it in half. After 2 half-lives, it now becomes 1.5 kilograms. All right, after 3 half-lives, it would become 0.75 kilograms. And remember, the time for that would be another 30.2 years, which would make it 90.6 years. Now, where are we going to? We're trying to go to 181.2 years. So how many more half-lives is that? Well, if I add 30.2 years to 90.6, I get 120.8 years. Still not enough. If I add another 30.2 years to that, I get 151 years. Not enough still. If I add another 30.2 years to that, I get 181.2 years. Good news. That means I went through a 4th, 5th, and 6th half-life. Why is that good news? Because it allows me to know how many times I need to cut this thing in half. So for the 4th half-life, I'm going to cut that 0.75 in half. That's going to give me 0.375 kilograms. For the 5th half-life, I'm going to cut that 0.375 in half again, and that's going to give me 0.1875, I believe. And then I'm going to cut it in half one more time, and that's going to give me about 0.09375. All right? The original question wanted to know how much will remain. So we needed our answer in kilograms. Well, this is how much was left after 181.2 years. So our final answer would be 0.0937 kilograms about. That's how much was left after 181.2 years. All right, Chem fam, let's do one more. Let's jump to number 5. It says cobalt-60 has a half-life of 5.3 years. So we know every 5.3 years, half of the mass, 50% of the mass, is going to go away due to nuclear decay. The thing was put into storage for 21.2 years. We know that after 21.2 years, it contains 14.5 grams. We want to know how much was present when it was first put into storage, meaning we want to know how many grams did it start off as. Well, we can do that with our half-life problems. Let's start. Here's our half-life. Here's our mass, and our time looks like it's going to be in years again, like the last problem we did. All right, we know that 0 half-lives means 0 years have gone by, and unfortunately, we do not know the mass that it started off with. However, we do know that this thing sat for 21.2 years, and every 5.3 years is a half-life. So that means as 1 half-life went by, 5.3 years passed. If 2 half-lives went by, another 5.3 years passed, which is 10.6 years. All right. If another half-life went past, another 5.3 years passed, which means that about 15.9 years have passed because we just continue to add 5.3. And again, if 4th 4 half-lives pass, you end up with about 21.2 years total. Now, the reason we stopped at 21.2 years is because we know this object sat for 21.2 years. We also know that 14.5 grams of the substance was present after the 21 years. Now, we want to work our way backwards to get to the front. By front, I just mean to the top. So, let's go backwards. 14.5 came from something that got cut in half. So if we double 14.5, do times 2, we get 29 grams. Now, that 29 grams came from something that was cut in half. So we have to double it to go back in time. So 29 times 2 is 58 grams. And again, we have to double the 58 grams to get it back to what it was after 1 half-life was 116. Double it again to get to the front or the top, and you end up getting 232 grams. So this whole process, we just kept multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2 to get our initial mass, which was 232 grams overall. It makes sense. Half-life means that after every single half-life, this object splits in half, splits in half, splits in half, splits in half. Why? Because of nuclear decay. But then you end up with your right answer. You just have to figure out what exactly you're looking for and solve the puzzle by using the pieces of information you already have. All right, thanks, ChemFam, for listening. That's 2 more examples, hopefully a little bit more helpful for you.